just so happens that I'm working on black and blue here, which is an experimental work. At the same time that I'm thinking about how can we develop something different that hasn't been tried before, which is probably impossible. But with the use of AI and all of the information it has, could it come up with a combination of something that a human has not tried? So this whole idea of microtonal music from the previous video, art is not music, it's not a sound. So the idea of microtonal is there are sounds between notes. If you go back and look at that music video, the guy has got additional frets on his guitar that will create the tone between notes. So, and then the process is more like math and seeing it in a mathematical way. So microtonal math rock. What I thought is I would upload black and blue to ChatGPT, and we're going to do this on video. I haven't seen what comes up. We're going to find out right now. But have it try to develop the idea. What would it do? So let's just see here. So what should I say? We're definitely going to say microtonal math, which again, what would the computer, how would the computer equate tones and music, sounds, with a visual piece? What's it going to come up with? So let's say here. Let's see, develop this painting into a work of microtonal math art. All right, we're going to start with that. Analyzing image. What you have here is already very strong. Those sweeping circular brush patterns feel almost like vector fields or fluid flow. To develop this into microtonal math art, we can treat your painting not just as an image, but as a visualization of continuous variation, like music that lives between notes. I'll guide you in a way that keeps it artistic, not overly technical, but grounded in real math concepts. Number one, reframe the painting as a field. This is the core idea. Think of your swirls as representing a continuous function rather than random strokes. Each swirl equals a wave or oscillation. The blue highlights equal peaks, higher frequency or intensity. The dark areas equal low amplitude / silence. So conceptually, your painting becomes a 2D map of microtonal frequencies flowing through space. Number 2, introduce microtonal structure, the math layer. Microtonal music divides notes into smaller steps than standard scales. Translate that visually. Instead of big color jumps, use tiny gradient shifts. Create bands or paths where color slowly shifts in very small increments. Okay, we've got these brush strokes that are showing up. That we can use that in these brush strokes. What to add? Thin, almost invisible frequency lines following your swirl patterns. Each line slightly different in hue, like 1/24th tone steps instead of 1/12th. Example idea. One swirl goes from deep navy to blue to teal to cyan in 20+ micro steps. Number 3, embed mathematical patterns. Now layer in subtle math structures without ruining the organic look. A, isolines like topographic maps. Add faint contour lines that follow the curves. These represent equal frequency values. B, parametric curves. Your existing strokes already resemble spirals. I don't know what this is. Lissajous curves. Lissajous curves. Turbulence patterns. Enhance them by repeating similar curves at slightly shifted scales, creating echoes in the same motion. Four, microtonal grid, hidden structure. Overlay a non-uniform grid, not straight lines. Instead, warp the grid to follow the flow of the painting. Spacing between lines should vary, like uneven tuning systems. This represents non-equal temperament tuning, very important in microtonal math. Non-equal temperament tuning. Okay, 5. 8. Okay, there's 8 points here. Number 5. Color equals frequency mapping. Assign meaning to color. Dark black equals 0 / base frequency. Blue equals low frequency. Bright electric blue equals high frequency spikes. Then introduce slight color shifts that are almost invisible. This gives that microtone feeling visually. 6, add discrete nodes. mathematical anchors. Place small intentional points where swirls intersect. Energy seems strongest. These represent harmonic nodes, resonance points. You can make them slightly brighter or geometrically precise, tiny circles or dots. 7, optional advanced layer if you want to go further. Tune it into a true math art hybrid. Map brush directions to angles. Map brightness to amplitude. Treat the whole piece like, then it gives a mathematical equation. You don't have to calculate it, just paint as if it follows a rule. Okay? All right, 8, title concept, important for meaning. To complete it as math art, give it a conceptual identity. Here's some examples. Non-equal field number 1. Microtonal flow study. Continuous frequency surface. Between notes, blue system. And then final vision, what you're creating becomes a visual composition where every stroke behaves like a frequency. Every color shift represents microtonal variation, and the entire surface reads as a continuous mathematical soundscape. And then it says, if you want, I can sketch a next layer directly on your painting concept, or translate this into a step-by-step painting session plan so you can physically execute it without guessing. Isn't this amazing? So I'm asking it to combine 2 completely different things, and what would it come up with? How did it find the middle ground to where it will work? So what should we do here? Sketch a next layer directly on your painting concept? Let's do that. Let's see what it comes up with. Creating image. Mathematical waves and glowing patterns. So it's working a layer on top of this to head in the direction that I'm asking for. Still creating image. It's really working pretty hard here. Trying to find the math in this. It's coming through. We're down to here. Okay, boom. Okay, let's make this bigger here. Yeah, it's following the pattern of the brush strokes. There's a lot to think about. So this is just the first step, and I might try a different prompt to get it to do something different. But here's the beginning of an idea, and we'll see how this develops.